So if you have conductivity, you can make it into resistivity. 1 over conductivity will give you resistivity. So the fluid itself inside the concrete, it has conductivity and resistivity. So we use it to measure this property and measure the resistivity and include it in measuring, the chloride migration inside the concrete. So this is the method. This is how it increases. If you can see, for this one, with this color, is it purple? It's for PC. It has higher. Also, when it has higher diffusion coefficient also. So C, LC3 and FA has the lowest also here. So this is the result for formation factor and instantaneous diffusion coefficient. So if you can see from the table, this one, LC3 has 0.3 and 0.69, but this normal PC, normal concrete has 3.8 and 7.6, so higher value. So, and also if you see FA, it has 0.2 and 0.56, and these two are the best, FA and LC3. And you can see from the graph, it's showing this. This yellow is LC3, the blue is FA. So you see at the bottom. So then after we use this, then we go to diffusion modeling again. Apparent diffusion coefficient, chloride, using in concrete, there is what you call, in concrete, when salt passed through in the concrete, there is what you call binding chloride and free chloride. In the concrete, when chloride or water with salt pass through the concrete, there are some amount that is chemically or physically attached to the concrete. So though that's attached one, we call it binding chloride. It has no effect because it is not free that will go into the reinforcement, that is the bar, steel bar, and cause corrosion. So we call it bonded chloride, sorry, and we have free chloride. The one that is inside the concrete, that is when it is passed through, the concrete absorbs some in its body, absorb it up using chemical or physical reaction and attach it. It will not allow it to move. So we call it binding chloride. And there is free chloride, the one that is free, that is not have been cut. Let's say like 10 chloride ion pass into the concrete. So let's say the concrete consume like 7 or like consume like 5. This means we have 5 free chloride and 5 binded chloride. So if we like it absorbs 3, we have like 7 binded chloride, 3 binded chloride and 7 free chloride. So that free chloride is one that has problem. It's one that causes corrosion. So we like concrete that has higher binding capacity, that can absorb as many as possible chloride ions to prevent it from what? Corrosion. So in all the methods above that I have already mentioned, we don't consider this binding chloride. We don't consider what? Binding chloride. So we want to test and see how this binding chloride can affect, or how the result will be if we include binding chloride in terms of passing of chloride into the concrete. So there is one method, that Brown-Yard method. We use that Brown-Yard method to calculate using like the density of the concrete, accessible water porosity, that is the porosity that concrete pass itself. When in a concrete, there are some porous spaces that are divided. There is what we call gel porosity. We have like water porosity. When that hydration occurs, there is some gel that reacts with water. After the reaction, some water will go. Then they will leave some hole. We call porous, some layer that is porous. And there is amount of water into the concrete when after hydration that is not absorbed by the concrete, that is not absorbed by the hydration. Then after it will dry off, then it will leave another porosity. So this accessible water porosity, we consider it with binding chloride of the concrete and density of the concrete. And then we calculated the formation factor method using that instantaneous.
Excuse me, engineer.
So yeah.
Excuse me, engineer, please, we need
Okay.
to be a little faster due to the time factor.
Okay, sorry.
Yes.
I'm the end
Thank
of
you.
it. So we calculated the population factor. So binding reduce the apparent diffusion coefficient. When you use binding, using binding properties, it also reduce the diffusion properties because it absorbs some chloride into the concrete and use it. So particularly in FA and LC3, formation factor derived diffusion coefficient show good agreement with the one that we did. The values is like less than 5% difference. This is the regression showing the relationship between with RC square of 0.1965. This is how two results agree with itself. This means they are correct. So key observation in this experiment, XCM, that is concurrent with supplementary cementitious material, improve pore structure, that is electrical resistivity and cooler transport resistance. LC3 and FA concrete deliver superior performance with significant reduction of carbon dioxide. We remove some amount of carbon dioxide because we replace cement that produce 8% to 10% of carbon dioxide in the atmosphere. So when you remove this and replace it with other, this means you reduce the amount of carbon dioxide. Then formation factor modeling enables rapid and non-destructive estimation of transport material, aligning with RCM marking. So non-destructive because you have already embedded the pins into the concrete without destroying or without destroying the specimen. You can test as many as possible for many years if you like. So this result support performance-based design for service life prediction in chloride environment. So conclusion, all SCM concrete significantly outperform PC in chloride ingredient resistance. Then LC3 ternary blend exhibit highest resistivity and lowest diffusion coefficient. Then resistivity-based diffusion estimates closely match with the two are close to each other. But letting combine use, you can use both because they are close to each other using the method that we did. Multi-technique assessment provide robust input parameters for durability design. Then SCM adoption support sustainable construction through embodied carbon dioxide reduction and extend service life. So thank you so much. So if you have any question, so you are free to. Thank you so much.
Okay, thank you, engineer, for this wonderful presentation. It was well explained. After the citation, I was eager to hear the presentation, but by God, I was impressed. He said everything in details. Thank you for sharing your knowledge with us. And as a civil engineer, indeed, I have gained a lot. So before we proceed, I would like to acknowledge the presence of engineer Amina Sallo. Ma, you are highly welcome. She's one of our past chairmen of the chapter. Thank you, Ma, for joining this meeting. Any questions, please? Any questions?
No question, maybe you don't understand. If you see no questions, maybe people don't understand. Yes, it's the same that people don't understand.
You explained everything in details. At first, I had a question, but before the end of your lecture, I've already answered the question. So I think that was what actually happened.
I don't have a question. What I have is a recommendation, because while reading the citation, I was wondering, wow, this is somebody who really knows engineering. And when we went through what she gave us, it was even more bombastic, so to say. So I wish to thank the presenter for a well-presented paper, a well-researched paper, and the education you have added to what we have learned in engineering. Thank you very much.
I have a question. Can I go ahead, please?
Yes, you can.
Okay. I don't know.
Hello?
Maybe you have said it. It just skipped. You said during the data collection, you took the data for more than a year.
Yes.
So my question is, did you use the same cubes throughout the experiment, or you changed the cubes for a particular period of time?
Never change the cubes, because just like continuous process. If you change cubes, this means you change the reading. The same cubes I've used. And also model it. I also produce some models for 100 years service life for corrosion, chloride integration, corrosion, and chloride induced corrosion and carbonation induced corrosion. I have modeled it for 100 years at different locations in Dubai using climate data by using different climate scenario. That is global warming, different climate scenarios to the mid carbon dioxide and the highest amount of carbon dioxide over 100 years at different locations. I did in Dubai, Seoul, Dublin, and there are some that I did in London, some in Paris, and Marseille. You call it Marseille in Paris, France also. So I never changed the cubes actually. And I use FIB model code to model it for 100 years and see the sustainability and also durability and which cover is more sustainable that can prevent the concrete in 100 years to come without causing problem.
Good evening.
Good evening.
I would like to ask a question.
Good evening. Madam Asanu.
We can hear you. Okay, I want to ask a question.
Okay.
During the curing process, as you said earlier,
Yeah.
did you measure the content of chlorine within the water that you used for that curing?
No, I didn't use in my curing, I never use salt. Do you understand? I use normal water, potable water.
Oh,
Like the amount in testing, like in testing the chloride, the NT build, sorry, yes, rapid chloride migration test, I use 0.1% chloride salt. Not in curing, but in the test. I use chloride in the test, not in curing. Curing is normal potable water, sorry.
Please, in case it expires, you can join using the same link, this particular link. You rejoin using this particular link.
Okay.
Let's make it snappy. Let's be fast so that we'll just conclude.
We have
Madam Amina, did I answer your question, please?
We have Sani Abba raising his hands. Please go. If you have a question, you can ask. You have Engineer Sani Abba. I don't know.
Yeah, Assalamu alaikum.
Wa alaikum assalam.
This is Dr. Sani from Saudi Arabia.
Doctor.
Thank you very much, the presenter and the organizers. I enjoyed the presentation, and I'm happy to see this kind of gathering, especially women in engineering. This is something that a very good things to do. Actually, it wasn't something surprising based on the well-known fact from the presenter. I have known the presenter for more than a decade, and I know this is not surprising presenting this kind of core engineering application. My question is actually one or two. Let me say that this kind of application, how do you see it in the real, like in terms of spatial things, climate, and other applications? Like we are in Africa, and you conducted this, I believe, in UK, right? And what are the certain things in terms of markets, in terms of globalizations? How do you globalize the research? Can it be applicable or marketable well in our own regions? This is my question.
Okay. Yes, you say have two questions. Maybe it's one. You forget and said two. So, yeah, this is applicable because my mind is always in Nigeria. All what I want to do, the reason why I took my topic is because of Nigeria. My topic is on carbonation and chloride ingression. Like in Nigeria, if you go to like Lagos and some part of the countries like Port Harcourt, especially southern parts, and also because there is exploration of the crude oil, they have high amount of carbon dioxide in the atmosphere there. So this means there is a high risk of carbonation. If you go to Lagos, you can see many buildings with rust, with corrosion. Do you understand? With spalling covers, something like that. But we don't even know what caused this problem. Because of carbonation, first, then chloride ingredient. Because they are in the coastal area, there is a bond, airborne, we have different environment. We have X3, we have X1. X1, in terms of chloride, it is airborne. That is coastal area, the salt that can come to the structure through the air. And we have X3, we call it tidal and splash zone, where the concrete is inside the water, come and touch the concrete and see. So we have different kind of this problem, especially in southern area. So that's why I propose this. And for carbonation, like we have petroleum at commercial quantity, like in Kolmani, that is in Bauchi, and we have, it is close to Lake Chad. So we have the relative humidity and everything there that has the possibility of happening, corrosion happening to the structures. So that's why. So this LC3, it is made of clay, abundant clay. Like in Nigeria, we have abundant clay, and we have abundant limestone. It is one that Dangote is using, Bua is using. So we can produce this in Nigeria at cheaper rates. Do you understand? We can use it, and also at coastal area. That's why I want to propose this after maybe when I come back in Nigeria. And even the salts, like here, in measuring the salt that will, like in my modeling, I use like the type of chloride, surface chloride, we have to calculate it. So like in Nigeria, I can even go and test and take the seawater and measure it for modeling. So it is possible because of, I did it because of Nigeria, not UK or any country.
Thank you.
Yeah.
Thank you, Doctor.
You're welcome.
Okay. Next on the agenda, we have the presentation of certificate for our chair.
Okay, thank you so much, General Secretary. Thank you so much, Engineer, for this insightful, well-articulated, detailed presentation. I'm sure all of us here have gained a lot from your presentation. Thank you so much for sparing the time and effort to make this happen. On behalf of the Professional Women Engineers of Nigeria, Kano chapter, I present this certificate to Engineer Salim Idris Malami in recognition of your paper presentation titled Durability Assessment of Low Carbon Concrete Using Electrical Resistivity, Chloride Migration, and Diffusion Modeling during the APWEN Kano-Nigeria meeting and technical session today, 26th November 2025. Thank you so much, Engineer, for giving us your time.
Thank you so much. I really
You're
appreciate
welcome.
your
You're
invitation.
welcome. Thank you. All right. Thank you so much.
Next on the agenda, we have the AOB. Any other business?
Yes.
I have some questions. Okay, sorry.
Okay. No,
you
go
say
ahead.
you have questions. So can I go? And can I ask my question, please?
Yes, you are welcome.
So the chairman had mentioned that they have some programs and some activities of planting trees and something like that. So is it for women only, or men can come in if someone wants to contribute, or it is specifically for you,
No,
female
it
engineers?
is not for the female. It is for everyone.
Okay.
It is for everyone. If you have a location or you want to give us trees, we are open to accept.
Okay.
Yes, and we're open to giving it to anybody that is in need of it.
Okay.
Anybody that has water available, that has the ability to take care of these trees, to nurture them.
Okay.
So we are open, yes, to all.
Thank you so much.
Any other business?
Yes, we were invited by the Matter Network to their annual conference coming this December. So I have the invitations. Anybody that is interested in going should please contact me so that I can give them the invitation cards. It's coming up, I think, on 6th of December next month. Yes, that's next month. So please, anybody that is interested in going to the conference should please let me know so that I can give them the invitation cards. As I will be absent next week, I will be at Inshallah Ibadan for the NSE conference. So please
Most
let
of
me
us
know
will be
before
in
then.
Ibadan at that time.
We will
Yeah,
be on
so
our way back. We are coming back on that very day. So we don't know what
yeah.
time we'll be back.
Okay.
You understand?